So in this video, I'm going to go over the PowerPoint for Lab 1, the orientation lab. And we'll start with looking at the background. So we went over this already when we went over the actual lab in LNL, the late night labs. But basically, again, to recap, the background for this orientation lab is to get yourself oriented to the virtual lab environment, how to conduct experiments in the virtual lab environment, make observations, gather and record all your data. So the rules of the scientific method are going to be used, especially when you're doing your lab write-up. So the scientific method allows a scientist to formulate a hypothesis, which is an educated guess or a prediction based on your previous knowledge, all right? And then you go about testing this hypothesis, okay? So we went through how to navigate in the virtual lab environment, especially locating the lab manual, which automatically appears when you open up the lab on the right hand side of the lab. And then you can move this lab manual around to a place where it gives you a good view of the lab while you're conducting the lab, all right? And there are different tabs that you navigate through, one of them being the background, and then the other being the procedure, and that's what you'll be using, basically the procedure when you're going through the lab, okay? So the background is good because it gives you all of that information required, and as pertaining the topic. And this also helps you in reinforcing what you learned in lecture or in the chapter. So then the procedure then details the steps that you need to do to conduct the experiment. And then you can record your lab notes as you go along when you click on the tab. So you can go back and forth between the procedure and the lab notes tab. So we talked about those three tabs, one for the containers, which is all the glassware, the materials, which is the chemicals, and then the instruments, which would be thermometers and balancers and pH meters, etc. Okay. So there is an unlimited supply of chemicals, containers, instruments, and if you're not careful, you'll be able to even blow up the lab, but since it's in the virtual environment, no harm done. So when you are adding things to say a test tube or any kind of glassware beaker, etc., make sure to drag that container or the chemical, drag it to the workbench and place that cursor right on top of that object into which you're pouring the liquid or the chemical, okay? So the cursor has to be exactly placed on top of that target, okay? And then you will get a box in which you can enter the amount of a material that you're going to add to the glassware. Okay. So make sure as you're writing down your notes in the lab notes tab that you're pressing save frequently, all right? Another suggestion that I would like you to incorporate is to make sure that you write those exact same notes on a notepad as you go along, just as a precautionary measure. Okay. Anytime you want to get rid of things, just drag it to the recycle bin or press on that button that says clear the bench. Okay. So the experiment starts with adding 5 ml of red cabbage extract to 5 different test tubes. All right. So the first test tube has water, the next is acetone, and so on. Okay. So you'll be noting the colors. Write your notes down in your lab notebook, and then you'll be attaching a pH meter to each of those test tubes from the instruments shelf. All right. So now you have a color as well as a pH number that corresponds to each solution as you're adding to those test tubes. So basically you had 5 test tubes, 5 mils of the red cabbage, which is an indicator, it's a colored dye. And then the first test tube has water, the second acetone, the third citric acid, the fourth 5% vinegar, and the fifth ammonia. And I believe there is a sixth with sodium carbonate, bicarbonate. I don't have it here in my PowerPoint, but you could do an added test if you wish in order to compare ammonia with the sodium carbonate or sodium bicarbonate. I don't recall which one it is. I think it's sodium bicarbonate, soda bicarb. So you're going to note the color after you've added these to the cabbage indicator, and then you're also going to note the pH by attaching a pH meter to all those test tubes. Okay, so you can zoom in and out using the plus minus tabs at the bottom of the screen. Clean up the lab, exit, and then go to assignments. Now write your name in the allotted space. Now this is optional. However, it's good practice to get into the habit of writing your name on your lab report. Okay. So enter your numbers and your observations in the table provided. Answer that question at the bottom of the table, and then type up your lab write-up under the assigned headings. Okay. So finish, double check that you've got everything. You can always pause, save, and come back to it if you don't have the time to complete the assignment. And then once you're done, just submit. Hit the submit button, and then I'll be able to see it and grade it. Okay. So the table should look something like this. The colors for water and acetone are blue, which means essentially they didn't change, and that's what's indicated by the pH meter. They're both 7 or neutral. The acids, citric and vinegar, are different shades of red. And the citric acid is 1.37 compared to vinegar, which is 2.55. So that difference in number shows that the citric acid is a lot more acidic, a bit of a stronger acid compared to vinegar. The ammonia, which is a base, is yellow, and so it has a higher pH, 11.78. Okay, and if you do another base such as the soda bicarb, you could compare ammonia and the soda bicarb to see how basic, because soda bicarb is a base, so you could compare it with ammonia to see which one is the stronger base or the stronger alkali. Excuse me. So the cabbage extract is not as accurate as the pH meter. This is because there's no number associated with it. You're simply looking at colors, and so it's not a very accurate way of determining which acid could be stronger or which acid weaker or which base stronger and which base is weaker. All right. If you have finite numbers, it's then easier to make that distinguishing feature between the acid which was less acidic as compared with the acid that was a stronger acid. Okay. So cabbage extract is not changing color for every possible pH, but some of the pH. So the aim here was to get familiar with the virtual lab environment as well as to use this both the cabbage extract and the pH meter to find the pH of the various I would call it solutions rather than liquids, and compare them to see which of them would be more accurate in determining pH. Okay. So my hypothesis is that the pH meter would be more accurate than the cabbage extract in making a distinguishing factor between acid strength and base strength. All right, so it would actually be able to show me which is more acidic or which is more basic and so on. Okay. And this is because the pH meter gives me actual pH numbers. So my prediction is that water would be neutral, the acids would be acidic, and ammonia would be basic. So again, make sure you write down all your materials, equipment, list your procedure. You have to be as detail oriented as possible. And then write down your data table, your observations. Now in the results section is where you're analyzing your data, all right? So this is where I'm saying that water and acetone are neutral and I justify why. And then ammonia is basic and then I explain why. So explanations for the data are given in the results section. In the conclusion section is the most important section, as I had mentioned before. Okay, this is where you opinionate whether your hypothesis was supported or not supported. Okay, so basically here my hypothesis that water and acetone are going to be neutral is supported, and that the acids are going to be acidic and so on. Right. So both the pH numbers and the cabbage indicator were helpful in determining which solution was neutral, which was acidic, and which was basic. Okay, and the pH meter was able to give finite numbers, which was able to help to explain the strengths of the acid and the strength of the base and so on. So what are the real world implications of this? Okay, so the real world implications of this experiment would be, suppose I wanted to test my the pH of my garden soil in case I'm a gardener, all right, and I needed my soil to be more alkaline, for example, all right, and it wasn't, then of course I needed to add something to make it more alkaline so that it would help grow that particular plant that prefers a more alkaline soil. Or if I needed the soil to be acidic, all right. So a quick way to test the soil would be to take some of that soil, dissolve it into water, and add some cabbage juice to it and see what color I get, right? So that way, if I had a pH meter, one of those portable pH meters, I could even test the pH of my soil. Now, this is just a real everyday application. How about in other ways, all right? If I wanted to, in terms of health and medicine, especially urine, blood pH is very critical to health, all right? And then urine pH is an indicator of disease, all right? So those are some of the things that you could research and elaborate on. Make sure that your conclusion section, you spend quite a bit of time and make it as detailed as possible. And that is the end of this particular video.